Hello everyone and welcome to the video on related rates. Alright, related rates. Ooh, fun stuff. Majority of times you see related rate problems, it's dealing with time and dealing with a function that's related to another function, and you have to take the derivative of that function and all that good stuff. So what I decided to do was I decided to do number 20 from the review worksheet. It is the one that's crossed out if you look on the answer key. The reason for that is because we actually did it in class, so I figured it was actually a pretty good one to put on a video, because it's one maybe you didn't try or whatever. So here's the video on how to do this. So first, read the problem. All edges of a cube are expanding at a rate of 5 centimeters per second. How fast is the volume changing when the edge is 8 centimeters? Okay. Now, I told you, when you're dealing with related rate problems, you're going to be given a formula, or you have to derive a formula, or something is going to happen in this. Now, again, this is just like a tutorial on how to get through these related rate problems. When you read this, it's talking about edges of a cube are expanding at a rate of 5 centimeters per second. How fast is the volume? There's a key word right there, volume, changing when the edge is 8 centimeters. So, obviously, we're looking at the volume of a cube. So, right away, you need to remember what the volume of a cube is. The volume equals, alright, I'm going to put x cubed. It's the side. X stands for an edge, okay, or the side, or side, alright. X is for the side, V is for volume. Alright, I like to write all this stuff down. Okay, then we read our problem. It says, all edges of a cube are expanding at a rate. Rate is the other nice little word that we have here. Rate deals with derivatives. Alright, when you see that, you're going to be taking the derivative of this formula. When you take the derivative of this formula, what happens is you're taking this derivative as in terms of time. That's what a rate does, okay? So we take this derivative as if we're kind of like implicit differentiation, where I'm taking the derivative of volume in terms of time, so that's why I have dv over dt. I'm taking the derivative of x, or edges, in terms of time, that's why I'm going to get this dx dt. Alright, you understand? So that's basically the derivative of our function here. Now, what's happened is we are actually given some of this information in the in the problem. Okay, it says all edges of the cube are expanding at a rate of 5 centimeters per second. That means the rate for the edge, this dx over dt, that's the rate for the edge's growth. That's equal to 5. And then it says how fast is the volume changing. So you want the rate of the volume, so we're looking for dv dt, and that's what we're looking for. And when the edge is 8, so then it tells you the edge is 8. So we have our little rate derivative here. We plug in everything that we know. We're looking for dv dt. We know that x is 8. We know that dv dt is 5. Right. That's Gus. And then we then plug in and solve. 8 squared is 64. 64 times 3 times 5 is 960, and it would be centimeters cubed per second. Alright, Alright, that would be our rate at which the volume is changing if these parameters are there. Alright, so basically when you're doing a related rate problem, whether it's, you know, a word problem or one of those other problems, basically it's kind of like implicit differentiation. You want to make sure that when you're taking the derivative, in this case we're taking the derivative of this in terms of time. So when you take the derivative of it, just make sure you account for the fact that you're doing it in terms of time. That's why this d over dt comes into play. Take the derivative, read the problem, figure out what these things represent. It's dealing with rate, that's the derivative of whatever it's talking about. If it tells you specifically edge, just make sure you just have it all listed. I like making this little list. And that's exactly how you do these related rate problems. Alright, thank you very much for watching, and I really hope this helps. Peace!